Hello everybody and welcome. My name is David Coombs from Thinscale Technology, and this is the first in a series of short videos demonstrating our new product, ThinIO. So today in this first presentation we're going to cover the installation and configuration of ThinIO and show you just how quick and simple it is to get up and running in your environment. So here we have our virtual machine that we're going to be using today. It's a Windows 7 x64 Service Pack 1 machine. Navigate to our installation media, and as you'll see with a very quick next finish through our MSI installer, we'll get the product installed. Okay, so as part of our installation we provide two management consoles. The first one is for configuration, which we'll cover off first. I'll just open that one up. And here is where we configure our ThinIO options. So the first thing we need to do is pick a cache size. This is the amount of physical memory we're going to allocate to the RAM cache for ThinIO. We'll leave it at our default of 350 megabytes. We need to specify a drive letter, which is the volume that we're going to be caching. This will default to the system or the boot volume of your machine. You are able to select different volumes if you have them available. And then we'll obviously select the mode. We default to disabled, but what we'll do here is just select enabled, save that configuration and close. And there we go. So ThinIO is now installed and configured, and to engage it we're just going to need to reboot our virtual machine. Okay, log back on. Okay, so now what I'd like to do is jump into our main management UI, which will provide us some very detailed stats of what ThinIO's doing under the hood. Okay, so our console does give you the option of connecting to remote machines, but for today's purposes we're just going to connect to this local machine. Okay, so first of all the important thing is to see that our cache is enabled. I will walk through each one of these graphs. If we start here at the top, this just gives us an indication of how much the cache has been used, what percentage of that cache has what we call got volatile data, so that's data that's been written, and our optimized data is reads, so it's data that's been read from the disk and is housed in our cache. So we can see already we're at a 94/6 split, so 94% of the data in our cache is currently volatile. That would have been all the writes that happened during the boot up and the login of this virtual machine. We have a total IOPS stats, so we have the complete amount of IOPS that Windows has requested and has been sent through to our disk, and versus that we have the amount that's been saved. So currently, as you can see, a lot more has been sent through than what we've been saved. This is quite typical in an environment during the boot. There's not a lot of savings without our read ahead technology enabled that we can do. The data has to be read from the disk. But importantly, you can see that we are making savings. This we can split down into the actual reads and writes in the system. So if we have a look at our actual again, so actual requests that have been sent down to the disk versus what's actually been requested. So if we take writes as an example here, we've got 4,822 write requests that have come from Windows, and we've actually only sent 607 of those down to the disk. So as you can see, there's a huge saving there on write IOPS. Probably most importantly is our percentage graph down here on the bottom right. This gives you a very quick indication of the percentage of requests that have come down from Windows and those that have been sent to the disk and those that have been satisfied by our RAM cache. As you can say, reads here, we're not making a great deal of savings on reads without our read ahead technology enabled. We've only cached 2% of those reads. But if we look at the writes here, as I say, just a simple boot and a login of this virtual machine, we've made an 87% saving. So only 13% of the writes that Windows has generated have actually been sent down to the disk subsystem. We do have some real-time stats as well. So as you can see here, we can get some very detailed information about what's going on in the system. It's not always obvious to see unless you've got perfmon and tools like that running in the background, but ThinIO is able to obviously monitor and give a very good indication of what's going on the system in terms of the writes and the reads coming through, what we're sending down to the disk, and what ThinIO is satisfying in its RAM cache. And there we have it. So as I say, just a very quick, short demonstration, the installation and configuration of ThinIO. I hope that demonstrated how quick and easy it is to get up in your environment. And as always, please visit our website for more information, and please check back soon for the second video in the series. Thank you.